Suppose the covariance matrix is given. We are asked to find the eigenvalues and eigenvectors, to find the principal components, find the proportion of variance extracted by the principal components. Open RStudio. Let's start entry the covariance matrix. First of all, declare a vector of the elements of the covariance matrix as A, run it. Now make it a matrix. Write CV matrix. Make it a 3 by 3 matrix. And run it. Here's the covariance matrix. Now we have to find the eigenvalues and eigenvectors. To find it, you can write the code eigen of CV run it. Here's the eigenvalues, and these 3 columns indicates the 3 eigenvectors. You can extract the eigenvalues as $sign and write values and run it. As the eigenvalues extracted. Now also you can extract the eigenvectors. Run it, and you can also extract the individual eigenvectors. This is the eigenvector 1, eigenvector 2, and eigenvector 3. You can extract all of them as write S dot matrix, and here a vectors, and select the column 1 and write E1, run it. Here's the eigenvector extracted. Now you can extract the eigenvector 2. Also you can eigenvector 3. See, the 3 eigenvectors are extracted here. These eigenvectors are actually normalized eigenvectors, or you can call it edge standardized, because the sum of the squares of the elements of the eigenvector will be 1. You can test it by running this code. See it 1. You can test for the next 2 vectors also. It is 1. Also it is 1. So as the eigenvectors are normalized, you don't need to normalize it again. If it was raw eigenvectors, you have to normalize it. These are the required eigenvectors to find the principal component. Also you can round these values. To round these values, for example, eigenvalues digits 3. Say that it is rounded and also you can round the eigenvectors. You can round the extracted eigenvectors, eigenvectors 1, 2, and 3. Round AV1, round. Before rounding it, you can write s dot matrix in the round function. Write E1 digits equal to 3. This is the first eigenvector is rounded here. Also, you can write around the next 2 eigenvectors also. See, all these are rounded up to 3 decimal places. Now, from these eigenvectors, you can obtain the eigenvector edge. E1 transverse. First 0.232 minus 0.973, 0.019, x1, x2, x3. Then 0.232 into x1 minus 0.973 to 0.019 x3. So these each the first principal component. You can obtain the second and third principal component also using the second eigenvector and the third eigenvectors. Make it as linear combinations. To find out the proportion of variance extracted by the principal components for the first principal component, variance extracted by first principal component edge, it will be first eigenvalue divided by the sum of the eigenvalues, 9.238 divided by 9.238 plus 4.889 plus 2.873. Now multiply it by 100%, 54.34 first principal component. You can also find out the second find out for the second and third eigenvectors, second and the third principal components in the same way. So that's it.